The answer is
Uh-oh. There we go. Okay, so like I said, we're going to talk about some things that you already know and maybe look at some integrals that you maybe didn't think about doing it in that particular way. But of course, some strategies to help you when you come across an integral. So first thing, I want you to remember the rule for arc sine and arc tangent. Okay, and for fun, why not arcsecant? Okay, so if you have the integral of 1 over the square root of a squared minus u squared, this would be your antiderivative. Okay, 1 over a squared plus u squared, that would be your arctangent. Those two are going to be the most popular. I'm going to put arcsecant up there just for the heck of it. But you need to recognize arcsine and you need to recognize arctangent. Okay? I will make a big deal of that. Was this the best choice? I'm fine. Should we make a pod 1 instead?
It's fine, I'm just short. I'm sorry. Allison can't see. I'm sorry. It's just the tall people are over there in the front.
Darby and Hannah are going to
Maybe that'll help. And I slouch, so. Yeah. Nope, that doesn't. It's fine. I'm just
that better?
straddle these two. Okay. Is this better? I'll slide based on what I need to see.
Okay, well, Joe will be
Like,
that
I
up
thought
when he
I'm like, Darby, as long as there's nothing in that bottom little corner.
Okay. Yeah, I will have the worst posture I can.
Oh, Lord. Okay, do we have these written down?
I'm sorry.
Okay, so let me just. We are going to go through these 3 problems. Do they look similar? Yes, there's just one itty bitty change from one to the next. Okay, so we're going to start here. 4 over x squared plus 25. Does that look like a pattern that maybe you wrote down?
Perhaps.
Which pattern, Darby?
It looks like the arctangent pattern.
It looks like the arctangent pattern where u is x, right? And a is 5. Okay. Now, it is important to think about, okay, du would be the same as dx. If we had like a 4x squared, we would have to do a little bit of finagling with a u substitution there to get our integral to work out the right way. And we'll talk about that here pretty soon. But what we have is we have 4 times the integral of 1 over u squared plus 5 squared. Okay, so I'm going to kind of use that u substitution just so you can see what's happening. Okay, that is the arctangent rule. So what we have is 4 times our arctangent rule. What is our arctangent rule? Arctangent is 1 over a arctangent of u over a. And we know that u is x, so I'm just going to go ahead and replace it. Okay. So really we have 4/5 arctangent of x over 5 plus c. All right. Now, we have a minor change in our second integral. What appears?
An X.
An x. How is that helpful? Well, it's not the arctangent rule anymore, so that is unhelpful. Victoria? Nah, you can do a pretty slick u substitution, right? U can be x squared plus 25, which means du is 2x dx, okay? Well, we have 4x dx, so we can make that work, right? Okay, 2x dx gets replaced with du, so what we have is 2 times 1 over u du. 2x dx gets replaced with du. We have 4x dx. So we still have that 2 multiplied. All right, well, we know that the antiderivative of 1 over u is the natural log of the absolute value of u. What? That's what? You don't like it? Why did I drop my absolute value?
So it's gonna be
X squared plus 25 is always positive. I don't really. Okay. If you put it there, I'm not going to be upset. Okay. All right, our third one. We have 4x squared in the numerator. So we now can no longer do u substitution because we don't have that relationship from u to its derivative. Yes.
Did you have to do that fraction thing?
What fraction thing?
So when was the A and the B?
Well, we would not be able to because x squared plus 25 doesn't factor to something real to where we could do that. That is a great idea, and we'll talk about that here in about 2 weeks. Okay? Yes. Well, we can't just like throw a square root on there because it's not an equation, it's an expression.
Are we gonna do something with L'Hopital's rule?
Not yet.
Oh man.
Not yet. However, 4x squared compared to x squared plus 25. We have an improper fraction. It is. Do you see why it is improper? Now I know that both the numerator and the denominator will go to infinity, but 4x squared is going to be larger than x squared plus 25 only after a few values, right?
Yeah.
Obviously not with 0, obviously not with 1, but very quickly 4x squared is going to be bigger. So we have an improper fraction. And what can we do with an improper fraction?
We can make it a mixed number?
Well, kind of, yes. And we do that by
Division!
No.
Oh.
God.
Oh, no.
No.
Oh my goodness, this is like a blast from the past. I remember learning about this.
Big.
Why did I put all those zeros in there?
Because you need 'em!
That's why.
Okay, they're like our placeholders, right?
Oh my goodness, this is so much
Ew.
So x squared times what is 4x squared? 4. Remember when we divide, we take divisor times whatever number we just wrote. So 4x squared plus 0x plus 100. And we subtract. Okay. So we have 4 with a remainder of negative 100. Okay, let's recall how we write that when we did our division chapter in polynomials way back like 2 years ago.
We do 4, and then we do 100 over x squared plus 25.
All right, now that's something that we can integrate without a problem. Isn't that cool? I think it's pretty cool. Okay, so what happens? What happens is the antiderivative of 4 is 4x minus 100 times the antiderivative of 1 over x squared plus 25. We just went through that over there, okay? It is the arctangent pattern. So we have 1 over 5 arctangent of x over 5 plus c. There's a c right there. There we go. Okay? So our final answer would be 4x minus 20 arctangent of x over 5 plus c. Okay? One little bitty x can change our integral from something straightforward to something where we have to kind of take a couple turns. Okay. If you have an improper fraction where your numerator is bigger than your denominator, you can divide and use the quotient to help you. The quotient and the remainder, I guess I should say. Okay. All right. Get crazy. Does this look like one of the patterns that you have? Ish. Okay, which pattern does it look like? Arc sine, okay. Arc sine, we have 1 over the square root of a squared minus u squared, okay? Well, it doesn't look exactly like that. However, we could write this as x squared over the square root of 5 squared minus 2x cubed squared dx. Do you agree?
Yeah.
Okay. So then if I really wanted to make it look like exactly like the arc sine rule that we wrote down, we would want u to be 2x cubed, which means du would be 6x squared dx. Conveniently, we have an x squared dx, don't we? Okay. So what I would want you to do is I would want you to rewrite this to be 1/6 the integral of 1 over the square root of 5 squared minus u squared du. Okay, and now that mirrors almost exactly the rule that we wrote down. Yes?
I have a question. So in those equations where it's like a squared minus u squared, does the a have to be a number and the u
It
has
does.
to be okay?
It does. And thank you for asking that. The a is going to be some sort of constant. The u is going to be some sort of expression involving a variable. Most likely x, but you know, sometimes we get crazy and throw a y in there or a z. Yes, yes. Okay, so when we go back to write this as our arc sign rule, I feel like a seal when our arc sign. Okay, we have 1/6. Arc sign has the rule of it doesn't have a coefficient. We just talk about the arc sign of u over a. Okay, so final answer 1/6 arc sign of 2x cubed over 5 plus c. What?
Let's see this.
My C looks funny. Okay. Okay, at your pods, I want you to come up with what our plan of attack would be and go ahead and go through the integration process together.
I feel like this was somewhere. I feel like I've
I
seen
feel
this
like we
before.
definitely seen this before. This might have been a bonus question. And I missed it because I'm stupid.
What's my rule? That word is not allowed. I'm sure you've seen this problem more than once. If I'm being completely honest.
This is way easier than you thought.
Oh.
You know, I noticed you like turn your
Yeah.
page.
I just very lost.
Well, I'm really bad at drawing straight lines, just bringing it down. Yeah. Well, it's just like my hand is just like open.
Real lines have curves.
Right.
I was really like sorry.
Annalie, what's our first step? Okay, u equals x squared. Second step. Hannah.
Du is 2x dx.
So when we go to rewrite our integral, Emily, how do we do that?
Do 1/2 du equals x dx. You can just do.
Oh,
Oh, sorry.
no, that's fine. Excellent.
And then
No, go ahead.
Okay. 1/2 integral e to the u.
Good. I am perfectly fine with you showing or not showing that step right there. Okay? I know last year we did. I know some of us can go from here to here without writing that step. So whatever works best for you, I want you to know I'm flexible with that. Okay? So what's the antiderivative of e to the u?
E to the u.
I appreciate your enthusiasm. So we have 1/2 e to the u, which is x squared plus c. Very good. Some of these we have to just kind of see, is there a substitution available to make, or is there a rule that we need to be looking for? Okay? So as you go through this assignment, really be careful with, is u substitution available for me to use or not? Okay? What are some things we can look for when we're doing u substitution? Like what stuck out to you here in this problem? Okay, we have a power, and then here's 1 power less, right? We did that We'll come back to here. Here we have x squared plus 25, and the numerator was 1 power less. Okay? Now, those are the obvious ones, the ones with a polynomial inside. Okay? Sometimes not so obvious would be something like this.
Ooh.
Fifty-one.
51. Okay, thoughts about this one?
Haha, she's smiling. That means you got
Okay,
some
so
honesty.
you're remembering a relationship with the natural log of cosine and the tangent.
Yeah.
Okay. Hannah's remembering a relationship with the natural log of cosine and the tangent. Right? Okay? So if we were to try u substitution, because we have a composition here, if we were to try u substitution, what should we attempt to let u equal? Okay. If u is cosine, du is negative sine, do we have? No. Okay. That's what you said, tangent? Okay, if u is tangent, du would be secant squared x dx. Do we have secant squared x dx to replace? Oh, so maybe, and it's okay that we didn't get it on our first couple tries. We're going to persist, right? So maybe the natural log of the cosine. Okay. Well, let's take this derivative. 1 over what's inside times the derivative of what's inside.
Oh my goodness.
Wow, that says sine. Okay.
That's just fun.
Do we have what? It does. It does. Can't you tell? I know I'll fix it. No, because it's bothering me.
Guys, we need a code word for Joseph. Armageddon. Okay.
Armageddon.
Dude, Snowmageddon.
So what we have now is negative the integral of what? U du.
What the hell? Oh my goodness. That's just silly.
Why didn't we
I
just
love
start?
it. I like this one.
I mean, it's the same problem. It's the same problem.
You literally just come out.
Yeah.
Oh my goodness.
I agree. That would be interesting.
Oh. Ooh. I do not like that square.
And if you don't want to put the square there, if you want to put it over the quantity itself, that's fine. But I do want you to know that if a logarithm is squared, that's where it's going to go, or cubed, or whatever, kind of like when we square sine and all of those lovely trig functions. Okay. What do you say? One more example, and then I'll let you start your homework.
Yeah.
Not a bad way to start our chapter, right? I don't want you to panic.
I'm panicking.
Why are you panicking?
Just
Does this look like a pattern pattern I had you write down at the very,
It certainly does.
yeah, which one?
It probably.
The arctangent.
Arctangent, okay. This looks like the arctangent rule, and this is the one that I really wanted to show you, okay? The only problem is we don't have just x squared, we have like 2x squared, and we need to view it that way, because that is going to affect how we go through our process here, all right? So I know that it's really minor, but I do want you to think of this as like u being 2x, and so du is 2dx, okay? That relationship is going to be important, okay? So we're going to rewrite this as 1/2 the integral of 1 over 5 squared plus u squared, so that when we take our antiderivative, we can go ahead and say, all right, we have 1/2 times, is it 1 over a? 1 over a arctangent of u over a plus c. Okay. This could be one of those that, you know, like when we have the integral of cosine of 5x. Let me write that on the board so you can visualize it. How many of you use u substitution or just kind of remember we need a 1/5 outside? You just kind of remember that we need a 1/5 outside. This would be on that same playing field to where once you've done enough of these, when it's just like the 2x that's being squared, you might be able to like skip over writing down that u substitution step. But if you have, you know, like that example when we had like 2x cubed squared or whatever it was, you would definitely need to show that u substitution. Okay. All right, so that's really all the examples I wanted to do today. You have 12 minutes. I encourage you to please begin your assignment while you have each other and myself to kind of think through some of these. All right, I know we kind of have to get back on that integration track.
The integration station.
Yeah, the integration station. I have this books.
Okay, we can use my picture.